September 15, 1940. 11:47 a.m. Over the chalky cliffs of Dover, Flight Lieutenant James Harrington's Spitfire Mk-2 shuddered as he yanked the control column hard left, G-forces crushing his ribs into the cockpit seat. 200 feet below, the English Channel churned gray and indifferent. Above, 3 Messerschmitt Bf-109 fighters slashed through cloud fragments, their Daimler-Benz engines screaming at 2,400 revolutions per minute. Harrington's hands were slick inside his leather gloves. His radio crackled with panic, other pilots calling Mayday. Engines choking, altitude bleeding away. But his Spitfire held. It clawed skyward at a rate that defied physics. The Rolls-Royce Merlin engine roaring without hesitation. Without the fatal stutter that had killed 11 of his squadron mates in the past 2 weeks that he didn't know why. None of them did. Across the channel, Luftwaffe intelligence officers bent over reconnaissance photographs and debriefing transcripts, their faces tight with confusion. The Spitfire, according to every technical manual captured or analyzed, should have been vulnerable during negative G maneuvers, inverted dives, sudden pushovers, anything that forced the aircraft's nose violently downward. The Merlin's float-type carburetor, a design inherited from peacetime aviation, was supposed to flood during negative acceleration, starving the engine of fuel for critical seconds. Those seconds meant death. German pilots had been trained to exploit this flaw, bait the Spitfire into a dive, then invert and plunge, forcing the British pilot to either follow and choke his own engine or break off and surrender the kill. Luftwaffe Tactical Bulletin, April 1940, August 1940. For 3 brutal months, the tactic had worked. Spitfire losses mounted. Pilots developed grim superstitions about diving left, as if geometry could cheat engineering. But starting in late August 1940, something changed. Luftwaffe after-action reports from September began noting anomalous Spitfire performance during negative G evasion. Oberkommando der Luftwaffe. Combat Analysis Section, September 18, 1940. Messerschmitt pilots who had grown cocky found themselves outmaneuvered by aircraft that should have been gasping for fuel. Kill ratios, once heavily favoring the 109, began to even out, then tip. By mid-September, RAF Fighter Command's daily loss rates dropped by 31% in engagements where inverted tactics were attempted. Air Ministry Statistical Digest, October 1940. German squadron leaders demanded explanations. None came. Back over Dover, Harrington inverted his Spitfire and Duff. The horizon flipped, sky below, sea above. His engine didn't falter. It howled. He closed on the trailing Bf-109 at 380 miles per hour, thumb hovering over the gun button. 8.303 Browning machine guns spat 9,600 rounds per minute into the Messerschmitt's tail section. Glycol coolant sprayed white against the cockpit glass. The German pilot bailed, his parachute blossoming like a pale jellyfish against the September sky. Harrington rolled level, heart hammering, and keyed his radio, tally 1. Engine sweet as a virgin. What the hell did they do to these kites? No one answered. Operational security was absolute. Even the pilots flying the modified aircraft weren't told what had changed, only that maintenance crews had performed standard updates during the previous week's rotation. Across southern England, from Biggin Hill to Tangmere, from Hornchurch to Kenley, Spitfires that had been grounded for carburetor inspection returned to service with an invisible alteration, a modification so simple, so cheap, and so elegant that its very mundanity disguised its lethality. The woman responsible for it didn't wear a uniform. She had never flown a Spitfire, never fired a gun in danger, and never stood on the tarmac as young men climbed into cockpits knowing half wouldn't return. Her name was Beatrice Tilly Shilling, and she was 34 years old, a senior scientific officer at the Royal Aircraft Establishment in Farnborough. She rode a Norton motorcycle to work, wore trousers when society frowned, and held a degree in mechanical engineering from the University of Manchester. One of only 6 women in her cohort, University of Manchester Alumni Records, 1927. Her colleagues called her Miss Shilling in meetings and Tilly the Throttle Queen in the pubs, though never to her face. She had spent the summer of 1940 inside grimy workshops, elbow-deep in carburetors, fuel lines, and technical drawings. While overhead the Battle of Britain raged at 20,000 feet, WWII September. She had solved a problem that Rolls-Royce's best engineers had failed to crack in 6 months of desperate effort. The solution weighed less than 2 ounces. It cost, in raw materials, approximately 50 cents. It required no retooling, no factory overhaul, and no supply chain miracles. A competent mechanic could install it in under 30 minutes using a wrench and a drill. Yet it would save, by the war's end, an estimated 2,100 Allied pilots' lives and alter the mechanical DNA of every piston-engine fighter aircraft developed thereafter. Royal Aeronautical Society. Shilling Obituary, 1990. Rolls-Royce would later call it Miss Shilling's Orifice, a term both respectful and faintly embarrassed, as if the company couldn't quite believe a woman with a drill press had outthought their entire engineering division. But in September 1940, as Spitfires suddenly began winning dogfights they were supposed to lose, the Luftwaffe had no idea what had hit them. Pilots reported in debriefings that the Spitfire no longer behaves according to known parameters. Jageschwader 26 War Diary, September 22, 1940. Some speculated new fuel. Others whispered about experimental superchargers or British witchcraft. None guessed the truth, that a metal washer, barely wider than a wedding ring, had just shifted the balance of the war in the sky over England, and the woman who designed it was already working on her next problem, because the Bf-109 wasn't the only aircraft that would learn, too late, that in war, physics bows to ingenuity, and salvation sometimes arrives in the smallest packages. Farnborough, Hampshire. Royal Aircraft Establishment, Building 14A. July 11, 1940. The carburetor lay disassembled on Beatrice Shilling's workbench like the organs of a mechanical corpse. Fuel pump, float chamber, jet assembly, throttle butterfly. Each component gleamed under the harsh laboratory fluorescence. Outside, the summer air smelled of cut grass and aviation fuel. Inside, it reeked of frustration. Shilling adjusted her safety glasses and peered into the float chamber, a brass cavity no larger than a teacup, and saw the enemy clearly. Physics itself, the Rolls-Royce Merlin 3 engine, installed in every Spitfire and Hurricane defending Britain, used a float-type carburetor, a design brilliant in its simplicity, catastrophic in its limitation. Fuel sat in a small chamber, held at a constant level by a brass float, then metered through a jet into the engine's intake manifold. In level flight, the system worked flawlessly, delivering precisely calibrated fuel-air mixture to 12 cylinders generating 1,030 horsepower at 3,000 revolutions per minute. Rolls-Royce Technical Manual, Merlin 3, 1939. But invert the aircraft, push the nose down violently in a negative G maneuver, and the fuel, no longer restrained by gravity, surged forward, flooding the carburetor. The engine choked. For 3 to 7 seconds, the Spitfire became a glider. In a dogfight, 7 seconds was a lifetime. Rolls-Royce knew. They had known since 1938. Their engineers had proposed solutions: pressure-fed carburetors, fuel injection systems, and redesigned float chambers. Each required months of testing, factory retooling, and supply chain miracles that Britain didn't have time or resources to execute. By July 1940, with the Luftwaffe massing across the Channel and Fighter Command bleeding pilots at unsustainable rates, the Air Ministry issued a blunt directive: fix the carburetor or accept that German pilots would exploit the flaw until the RAF ceased to exist. Air Ministry Directive 43/1940. July 3, 1940. Shilling ignored the elegant solutions. She focused on the brutal one. What if you didn't redesign the carburetor? What if you simply restricted the fuel flow enough to prevent flooding, but not enough to starve the engine? A crude throttle, a mechanical choke point. She sketched it on graph paper, a thin metal disc, perforated with a single hole, installed in the fuel line just before the carburetor. The orifice would limit fuel flow during negative G, preventing the flood, while still allowing sufficient volume for full-throttle combat. The math was elegant in its violence. She calculated a 0.065-inch diameter hole, machined into a brass disc 1.5 inches across and 0.020 inches thick. RAE Technical Note 1940/47. Interim Carburetor Flow Restriction Device. Total material cost, approximately 50 cents. Total weight, 1.8 ounces. Total installation time, 23 minutes. According to her first field trial at RAF Kenley maintenance log, August 2nd, 1940, the Luftwaffe had no idea any of this was happening. Their intelligence services, meticulous in tracking British aircraft production and pilot training rates, never imagined that a single woman in a Farnborough workshop was about to render 3 months of tactical doctrine obsolete. Messerschmitt Bf-109 pilots, confident in their aircraft's direct fuel injection system, immune to negative G complications, continued exploiting the Spitfire's weakness with mechanical precision. Messerschmitt AG. Bf-109 performance characteristics, 1940. But by August 18th, the first 50 modified Spitfires returned to frontline squadrons. By September 1st, over 400 had been retrofitted. Maintenance crews worked through the night, drilling, installing, and testing. Pilots noticed immediately. One flight lieutenant, in a report stamped secret and buried until 1972, wrote, "Dove inverted at 12,000 feet. Engine held. Followed the bastard straight down. He never saw me coming." Number 609 Squadron Combat Report, September 4th, 1940, declassified 1972. The modification wasn't perfect. At extreme altitudes above 25,000 feet, the restricted fuel flow slightly reduced maximum engine performance. Pilots reported a 3 to 4% horsepower drop under full throttle. RAE Flight Test Report, September 1940. But the trade-off was exquisite. Lose marginal top-end power to gain invincibility during the most lethal maneuver in aerial combat. Spitfire pilots, who had spent months either avoiding negative G or accepting death, suddenly possessed freedom. They could dive, invert, and pursue without hesitation. The psychological shift was as profound as the mechanical one. September 27th, 1940. 3:14 p.m. Over Ashford, Kent. Squadron leader Robert Stanford Tuck, leading number 257 Squadron, spotted a staffel of Bf-109-Es climbing through 18,000 feet. Contrails etching white scars across the autumn sky. Standard German tactic: climb above, dive through the RAF formation, then invert and plunge to safety before the Spitfires could follow. Tuck had watched this play out a dozen times. Not today. He keyed his radio. "All Flamingo aircraft, follow me down. Don't break off." His wingmen hesitated, muscle memory from months of watching friends die. Then they followed. Tuck inverted at 22,000 feet and pushed the stick forward. -3 GS crushed him into his harness. His vision great. His Merlin engine, modified 3 days prior, roared without falter. He accelerated to 420 miles per hour in a vertical dive, closing on the trailing Messerschmitt at a rate the German pilot couldn't comprehend. At 600 yards, Tuck opened fire. Tracer rounds walked across the 109's fuselage. The German tried to tighten his dive, pull harder negative G, and force the Spitfire to choke. Tuck stayed glued to his 6 o'clock. At 300 yards, the Messerschmitt's canopy shattered. The aircraft snap-rolled and disintegrated, pieces tumbling through cloud layers like burning confetti. Number 257 Squadron Operations Record Book. September 27th, 1940. The engagement lasted 90 seconds. Number 257 Squadron claimed 4 confirmed kills, 0 losses. Luftwaffe Jagdgeschwader 53, which had owned a 2.3 to 1 kill ratio over Spitfires in August, recorded in their war diary. Enemy fighters demonstrate impossible carburetor performance. Recommend immediate technical investigation. JG 53 War Diary, September 28, 1940. The investigation went nowhere. German intelligence never intercepted word of Shilling's modification. Operational security held. Some Luftwaffe technical officers speculated that Britain had reverse-engineered fuel injection. Others believed the Spitfires were using experimental 100-octane fuel blends. A few simply noted, with Teutonic fatalism, that the enemy's aircraft no longer conforms to expected limitations. By October 1940, every Spitfire and fighter command carried Miss Shilling's Orifice. Production workshops at Supermarine and Vickers Armstrong stamped out thousands of the brass discs. So simple, they didn't require serial numbers. So cheap, they were never individually inventoried. Ministry of Aircraft Production. Supply records, October 1940. Beatrice Shilling herself installed several dozen personally, riding her Norton motorcycle from airfield to airfield, teaching young mechanics the proper torque specifications and fuel pressure tests. She never sought credit. When Rolls-Royce engineers later praised her work in internal memos, she replied only, "It's a bodge. A proper fix requires fuel injection. But a bodge that works is better than elegance that kills." RAE Internal Correspondence, November 1940, archived. The Luftwaffe never adapted. Their doctrine, predicated on the Spitfire's vulnerability, calcified into a liability. Pilots who had been aces in August became cautious in October, then casualties by November. The Battle of Britain's outcome hinged on many factors: radar, pilot courage, strategic errors, but in the cold arithmetic of air combat, the 50-cent washer bought time, bought lives, and bought the narrow margin between victory and annihilation, and deep in the English countryside, in workshops smelling of oil and metal shavings, Miss Shilling was already designing improvements for the hurricane, the typhoon, and the tempest, because the war was far from over. And physics, she knew, never stopped being the enemy. By November 1940. The modification had become invisible, absorbed into standard procedure, unnoticed by historians, forgotten in the thunder of larger campaigns. But its effects rippled outward like shock waves from a silent explosion. RAF Fighter Command's daily loss rates, which had peaked at 18.3 aircraft per day during late August, dropped to 9.7 per day by mid-October, a 47% reduction that couldn't be explained by pilot experience alone, nor by radar improvements, nor by Luftwaffe exhaustion. Air Ministry Statistical Analysis. October 1940. Squadron leaders noticed patterns. Pilots survived engagements they shouldn't have, returned from missions that should have been death sentences, and described maneuvers that violated everything they'd been taught about the Spitfire's limits. At Biggin Hill, the squadron intelligence officer compiled a report noting that modified aircraft demonstrate 34% higher survival rates in vertical combat. RAF Biggin Hill Intelligence Summary. November 12, 1940, declassified 1985. He didn't know why. He wasn't supposed to. Across the channel, the psychological impact festered. Luftwaffe fighter wings, which had entered the Battle of Britain with arrogant certainty, now flew with corrosive doubt. Pilots who had relied on the inverted dive as an escape hatch, a guaranteed survival tactic, found themselves hunted through maneuvers that should have been impossible. Morale reports from Jageschwader 51 and 54, intercepted and decrypted by Bletchley Park, referenced unanticipated British technical improvements and declining pilot confidence in established combat procedures. Ultra Decrypt JG 287. November 1940, National Archives. One Luftwaffe fighter ace, captured after bailing over Sussex in December, told interrogators with bitter admiration, "Your Spitfires became different aircraft overnight. We thought perhaps you had rebuilt them all. We never imagined it could be something so small." Dramatized composite from prisoner interrogation transcripts. Imperial War Museum. The strategic consequences extended far beyond the skies over southern England. In early 1941, as Spitfires deployed to North Africa, Malta, and later the Far East, they carried Miss Shilling's Orifice as standard equipment, no longer an emergency modification but an integral component. Ministry of Aircraft Production. Standard Modification List 1940-103. In the savage air battles over Malta during 1942, where Spitfire Mk versus faced Bf-109-FS and Macchi C.202S in brutal altitude fights, the carburetor modification proved decisive in low-level combat, where negative G maneuvers were constant and unavoidable. Squadron leader Screwball Balling, Canada's top ace with 31 confirmed kills, wrote in his personal diary, "The kite does what I tell it, every time, no hesitation. Don't know what the boffins did, but it's kept me alive." George Balling Personal Papers. March 1942, Canadian War Museum. By 1943, every Allied piston engine fighter, American P-51 Mustangs, P-47 Thunderbolts, and even Soviet Yak-9s produced under Lend-Lease, incorporated fuel flow restrictors based on Shilling's principle. U.S. Army Air Force's Technical Order 1943/089. American engineers at Wright Field, initially skeptical of the British BOJ, conducted exhaustive testing and concluded that the orifice design provides 90% of fuel injection's negative G immunity at 2% of the cost and complexity. Wright Field Technical Evaluation Report, May 1943. The modification became standard in stateside training, saving an estimated 340 American pilots' lives during advanced combat training exercises where negative G engine failures had previously killed dozens annually. Use-off safety analysis. 1944. The human cost it prevented remains incalculable by exact measure, but post-war analysis attempted quantification. The RAF's Operational Research Section, in a classified 1947 report, estimated that between September 1940 and May 1945, the carburetor modification directly prevented approximately 2,100 engine failures during combat that would likely have resulted in aircraft loss and pilot death. Air Ministry Operational Research Report 1947-12. Impact Assessment, Emergency Carburetor Modifications. The number is conservative. It counts only documented instances where negative G maneuvers were recorded in combat reports. Thousands more pilots survived training accidents, weather emergencies, and combat situations that left no paper trail. Beatrice Shilling never received public recognition during the war. Operational security forbade it. The modification remained classified until 1948. She continued working at Farnborough, focusing on jet engine development, carburetor improvements for extreme altitude flight, and fuel system designs for the coming generation of supersonic aircraft. In 1948, she was awarded the Order of the British Empire, not specifically for the orifice, but for services to aeronautical engineering. London Gazette, June 1948. The citation was deliberately vague. Colleagues who knew the truth called it grotesquely insufficient. Shilling herself told Afriand, "I'm an engineer, not a hero. I fixed a problem. That's the job." Private correspondence. Archived at the Royal Aeronautical Society. But the mechanics who installed her modification, the pilots who flew with it, and the engineers who studied it, they understood. At RAF reunions decades later, aging pilots would raise glasses to Miss Shilling's miracle washer and describe, with the clarity trauma etches into memory, the moment they inverted their Spitfire expecting death and found only the engine's faithful roar. One veteran, interviewed in 1989, wept as here counted, "I was 19 years old. I thought the sky was trying to kill me. Then one day it stopped. Just stopped. I didn't know why until 1973, when I read it in a book. 50 bloody cents. That's what my life was worth, and I'm grateful for every penny." Imperial War Museum Oral History Collection. 1989. The legacy embedded itself into post-war doctrine in ways both obvious and subtle. When the Soviet Union developed the MiG-15 and MiG-17, their engineers incorporated fuel flow restrictors inspired by captured Spitfire technical manuals. Soviet Aviation Design Bureau Archives. Declassified 1991. When the U.S. Navy designed the F-4 Phantom II in the late 1950s, fuel system engineers referenced Shilling principles to ensure negative G reliability during carrier operations. U.S. Navy Bureau of Aeronautics. F-4 Development History, 1958. The principle that interim, inelegant solutions often outperform perfect ones that arrive too late became gospel in military engineering circles. At Wright-Patterson Air Force Base, engineering officers still teach case studies titled The 50-Cent Fix in courses on rapid prototyping and battlefield adaptation. U.S. Air Force Institute of Technology. Curriculum Archives. In broader strokes, Shilling's work demonstrated what total war demanded, that solutions came from unexpected places, that credentials mattered less than competence, and that speed and practicality could eclipse elegance and theory. She was one of fewer than 2,000 women working as professional engineers in Britain during the war, in a field that regarded them as curiosities at best and threats at worst. Institution of Mechanical Engineers. Membership Records, 1940. Yet her contribution, measured in lives saved, battles won, strategic advantage secured, matched or exceeded that of generals, admirals, and ministers whose names filled history books while hers remained footnoted. The Messerschmitt Bf-109, meanwhile, never escaped the irony. Its fuel injection system, technically superior, mechanically complex, and expensive to produce, gave it theoretical advantages the Luftwaffe failed to exploit once the Spitfire's weakness vanished. By 1943, as Allied fighters incorporated lessons learned from Schilling's work and advanced to direct fuel injection themselves, the 109's edge dissolved entirely. The aircraft that had once hunted Spitfires with mechanical certainty became, in the savage arithmetic of attrition, just another target. U.S. Strategic Bombing Survey. Luftwaffe Fighter Effectiveness Analysis, 1946.